Hello friends. I am Satish Lele. This video is part of my chemical process typing channel on YouTube. This video is about mass balance. Definition: the accounting of all mass in a chemical or pharmaceutical process is referred to as mass or material balance. Similarly, energy accounting is referred to energy balance. Uses: it is used in day-to-day operation of process for monitoring operating efficiency. It helps in making calculations for design and development of a process like quantities required, sizing equipment, number of items of equipment. Example of batch mixing process: 200 kilograms of a 40% weight by weight methanol and water solution is mixed with 100 kilograms of a 70% weight by weight methanol and water solution in a batch mixer unit. What is the final quantity and composition? Total initial mass equals total final mass equals 300 kilograms initial methanol mass equals final methanol mass. 80 plus 70 equals final methanol mass equals 150 kilograms. Therefore, final composition of batch is 150 divided by 300 into 100 equals 50% by weight. Batch processes. Batch processes operate to a batch cycle and are non-steady state. Materials are added to a vessel in one operation and then process is carried out and batch cycle repeated. Interval balances are carried out on batch processes where balances are carried out on the initial and final states of the system. Batch cycle. It depends on sequence of operations or steps repeated according to a cycle. Batch cycle time. Batch size.
Simple batch reaction cycle. In this there are 3 steps.
Continuous processes. These processes are continuous in nature and operate in steady state and balances are carried out over a fixed period of time. Materials enter and leave process continuously. Law of conservation of mass. When there is no net accumulation or depletion of mass in system steady state, then total mass entering system equals total mass leaving system, or total mass at start equals total final mass. General mass balance equation: input plus generation, output, consumption equals accumulation. Generation and consumption terms refer only to generation of products and consumption of reactants as a result of chemical reaction. If there is no chemical reaction, then these terms are zero. Applied to a system. Applied to total mass and component mass. Definitions: system is an arbitrary part or whole of a system. Steady state or non-steady state. Accumulation or depletion of mass in system. Basis for calculation of mass balance, unit of time, batch, etc. Component or substance. Exercise: 1,000 kilograms of a 10% by weight sodium chloride solution is concentrated to 50% in batch evaporator. Calculate product mass and mass of water evaporated from evaporator. Mixing of streams. Flow sheet preparation. Show all flow streams. Show operations and equipment in sequence. Use standard symbols. Flow sheet. It consists of process flow diagram and PID. Typical simple flow sheet arrangement. Exercise: a 1,000 kilograms batch of a pharmaceutical powder containing 5% by WD water is dried in a double cone dryer. After drying, 90% of the water has been removed. Calculate the final batch composition and the weight of water removed. The exercise in batch distillation. 1,000 kilograms of a 20% by WE mixture of acetone in water is separated by multi-stage batch distillation. The top product distillate contains 95% by weight acetone and the still contains 2% acetone. Calculate the amount of distillate. Use of molar quantities. It is often useful to calculate the mass balance using molar quantities of materials and to express composition as mole fraction or mole percent. Distillation is an example where equilibrium data is often expressed in mole fractions. Molar units. The mole is the molecular weight of a substance expressed in grams. To get the molecular weight of a substance, you need its molecular formula, and you can then add up the atomic weights of all the atoms in the molecule to get molecular weight. To convert from moles of a substance to grams, multiply by the molecular weight. To convert from grams to moles, divide by the molecular weight. Mole fraction is moles divided by total moles. Mole percent is mole fraction multiplied by 100. Molar units for benzene. Benzene is C6H6. The molecular weight is 6 into 12 plus 6 into 1 equals 78. So 1 mole of benzene is 78 grams. 1 kilomole is 78 kilograms. Molar units for toluene. Toluene is C7H8. The molecular weight is 7 into 12 plus 8 into 1 equals 92. So 1 mole of toluene is 92 grams. 1 kilomole of toluene is 92 kilograms. The exercise of batch distillation. 1,000 kilomole of an equimolar mixture of benzene and toluene is distilled in a multi-stage batch distillation unit. 90% of the benzene is in the top product distillate. The top product has a benzene mole fraction of 0.95. Calculate the quantities of top and bottom products and the composition of the bottom product. Mass balance of crystallizer. The crystallizer contains 1,000 kilograms of a saturated solution of potassium chloride at 80 degrees centigrade. It is required to crystallize 100 kilograms KCl from this solution. To what temperature must the solution be cooled? At 80 degrees centigrade, saturated solution contains 51.1 divided by 151.1 into 100% of KCl. It is 33.8% by weight. So in 1,000 kilograms there is 338 kilograms KCl and 662 kilograms water. Crystallizing 100 kilograms out of solution leaves the saturated solution containing 238 kilograms KCl and 662 kilograms water, which is 238 divided by 6.62 gram KCl per 100 gram water, which is 36 gram KCl divided by 100 gram. So temperature required is approximately 27 degrees centigrade from table in next slide. Mass balance, filtration and centrifuge. Mass balance dryer. Example of single-stage extraction. Immiscible solvent.
F equals 195 kilograms X of feed equals 0.1 kilograms product per kilogram of water. S equals 596 kilograms chloroform. Y equals 1.72 of X1, where Y1 is kilograms product per kilogram chloroform in extract and X1 is kilogram of product per kilogram water in raffinate. Note, chloroform and water are essentially immiscible.
Total balance 195 plus 596 equals E plus a feed 195 equals 19.5 mole of product plus 175.5 mole of water. Product balance 19.5 equals 175.5 of X1 plus 5960 Y1. 19.5 equals 175.5 of X1 plus 596.1.72 of X1. Hence X1 equals 0.0162 and Y1 equals 0.029. R is 175.5 kilogram water plus 2.84 kilogram product. And E is 596 kilogram chloroform plus 17.28 kilogram product. Mass balance of absorption unit. Mass balances of multiple units. Do overall balance. Do unit balances. Do component balances. Mass balance procedures. Process description. Flow sheet. Label. Assign algebraic symbols to unknown compositions, concentrations, quantities. Select basis. Write mass balance equations. Overall, total, component, unit. Solve equations for unknowns. Definitions. Stoichiometric quantities. Limiting reactants. Excess reactants. Conversion. Yield. Selectivity. Extent of reaction. Stoichiometry refers to quantities of reactants and products in a balanced chemical reaction. AA plus BB equals CC plus DB. The moles of a react with D moles of B to give C moles of C and D moles of DABCD are stoichiometric quantities. Limiting reactant and excess reactant. In practice, a reactant may be used in excess of the stoichiometric quantity for various reasons. In this case, the other reactant is limiting. It will limit the yield of products. The reactant is in excess if it is present in a quantity greater than its stoichiometric proportion. Percent excess equals moles supplied. Stoichiometric moles per stoichiometric moles into 100. Conversion. Fractional conversion equals amount reactant consumed per amount reactant supplied. Percent conversion equals fractional conversion into 100. Note, conversion may apply to single-pass reactor conversion or overall process conversion. Yield equals moles product divided by moles limiting reactant supplied into SF into 100. Where SF is the stoichiometric factor equals stoichiometric moles reactant required per mole of product. Selectivity equals moles product per moles reactant converted into F dot into 100. Or selectivity equals moles desired product per moles of byproduct. Extent of reaction equals moles of component leaving reactor, moles of component entering reactor per stoichiometric coefficient of component. Thanks for learning. If you like this video, please give a like to my channel and subscribe it.